Good day. This lesson is the continuation of the topic on calculus of vector fields. It is about sketching vector fields into space. There are two ways to sketch vector fields. One is point plotting, which is a tedious process, and the second one is through the use of an available computer software called MATLAB. Here are the objectives of this lesson. At the end of the lesson, you must be able to sketch a vector field into space from a given equation using point plotting, and sketch a vector field into space from a given equation using MATLAB. A vector field in the plane can be visualized as a collection of arrows with a given magnitude and direction, each attached to a point in the plane. Let us have this example. So it says here, we're going to sketch the vector field f given by f of xy equals negative yi plus xj. So this is what you're going to do. You prepare table values of xy and f of xy. You're going to assign values to xy, then solve for f of xy. So for example, we're going to assign the point 1, 0, the value for f of xy will be 0, 1. Because take note that we have here x is equal to 1, and if you're going to assign here now, this will be 1j, as indicated in the second component of your vector field f of xy. And for y here, which is 0, we have here the first component of your vector field f is 0. Then for the second point, which has coordinates 0, 1, so x will be 0. So in that case, we have this as 0j. And we write here now, the second component of your vector field f is 0. While you have here 1 for y, and in here, we have negative 1i. So that will be the component or first component of your vector field f. Then we go now to negative 1, 0. So this will be the value for x, and this will be the value for y. So substituting now in your vector field f, so we now have x is negative 1, so this will be negative j, and this will be 0i. So therefore, we have it as 0, negative 1. Then we have the point 0, negative 1. So this will be your x value, and this will be your y value. Substituting now in the vector field, so this will be, we have this as positive 1i, because y is negative 1, then plus 0j. So that's why we have here 1, 0. Then the next point is 3, 0. So this will be your x value, and this will be your y value. Substituting now in the vector field, so we have here now 0i plus 3j. That's why we have 0, 3. Then if we have now negative 3, 0, so this will be your x value, while this will be your y value. Substituting now in your vector field f, so 0 for 1i, so as you can see we have here 0, then x is negative 3j. So that's why we have negative 3. So you may continue assigning values of x and y as a point. And let's now graph these values that we have obtained. So we have here now the x and y coordinate system starting at 1, 0. So we have this as 1, 0 in the x axis. And then we will now plot 0, 1. So that means that we have 0 for that position of your x, or I should say I, and then 1 for j. That's why we have here the initial point, and this will be considered as the terminal point. So you connect these two endpoints that forms the vector, first vector rather. And then we go now to the second vector that has this as your initial point, and this will be your terminal point. So it's like that way. So 0, 1 is right here. If you have sketch 0, 1, sorry for that, you have this as 0, 1, and then you have negative 1, 0. So to plot negative 1, 0, so that means you go to the left because you have it as negative 1 for the x direction. Then for y, it is 0. So that means that is now your vector because we connect 0, 1 and negative 1, 0. Then we have negative 1, 0, which is at this point. So negative 1, 0 will be the initial point, and then the terminal point will be 0, negative 1. So where is that? So you have it as 0. So that is the direction of your x. So it is right here. And then y is negative 1. So it goes downward with length of 1. Then we have 0, negative 1. So this is your 0, negative 1. And then plotting now the vector component of your vector field. So we have here 1, 0. So that means you now have one value to the right and then 0 for the y vector or for the j vector. Then we continue with the set of points 3, 0, and then we have the vector 0, 3. So 3, 0 is right here. And then we now have the vector 0, 3 drawn in this manner. So we count 0 unit, then 3 units upward. And then we have negative 3, 0 is right here. And then we have it now as 0, negative 3. So the position will be 0 for x, and then for y it will be negative 3. So this will be your I and j. So you can continuously do that in the other values. So let's say you have it as 0, 3, or rather 0, negative 3. So this will be 0 for x, and then positive 3 for your y. So this will be, again, for the x, at this point it is 0, then, or rather for that x, it will be 3, and then for y, it will be 0. Here is the sketch of the given vector field f of xy equals negative yi plus xj using MATLAB. So as you can see, I have already here the command that we will use to graph the vector field. So we will use mesh width and quiver commands. So there will be a separate lesson for this. But for now, let us use this syntax to graph the given vector field f of xy equals negative yi plus xj. So we have here the syntax in the first line. So we have in bracket form, we have xy equals mesh width. Then we have the coordinates for the x, or for the values of x, that is from negative 5 to 5 with an increment of 1. Then for the y values, we have the limits from negative 5 to 5 with an increment of 1. Then the component u and v here are obtained by using the vector field. So for u, it will be negative y, which is also your I component. Then for vector v, that will be your j component, and that is equal to x. Then we will use the command quiver, and this will now help us to plot the given vector field with the given argument or syntax as you have to write xy UV separated by commas. Then when you press enter, you will see a figure that will come out like this. So as you can see, if you're going to expand this, this will have the same reflection of the graph that we have obtained a while ago. Let us somehow compare the two. So this is the graph using MATLAB. Then we have the graph using point plotting.